All right, let's dive in. In our whole DMAIC journey, if you think about define, measure, and analyze as the diagnostic phase, figuring out what's wrong, then the improve phase, well, that's when we actually administer the cure. This is the action-oriented heart of the entire process. It's where we finally stop asking why and start actively fixing things. Here's what we're going to cover. We'll talk about how this whole treatment plan gets started, moving from just thinking to actually doing. We'll look at generating and then testing potential cures, and then we'll see it all play out in a real-world case study. And finally, we'll talk about making sure those improvements actually stick around for good. Okay, so the improve phase, this is the real turning point in the whole DMAIC cycle. All that data you collected, all that root cause analysis, it's all been leading up to this exact moment. It's time to stop diagnosing and start doing. And honestly, this is the absolute best way to think about it. Imagine a doctor. They wouldn't just look at your symptoms and start guessing at a cure, right? Of course not. They run tests, they analyze the results, and then they prescribe a very specific, targeted treatment. That is exactly what we are doing here for our business processes. But, and this is a big but, to apply a cure that actually works, you have to trust your diagnosis. The solutions we come up with in this phase are only as good as the analysis that came before them. I mean, think about it. A brilliant solution for the wrong problem is still a total failure. So let's just step back and look at the big picture. We've defined the problem, we've measured our starting point, we've analyzed the heck out of the root causes, so naturally, improve is the very next step. It answers that huge, all-important question. Okay, so how are we going to fix this? It's the bridge that takes us from understanding the problem to actually sustaining the solution. So where do these amazing solutions come from? Well, the first part is all about creativity and strategy. It's about getting a whole bunch of potential cures on the table before we rush to a conclusion. And this process follows this really powerful two-step pattern. First, we use what's called divergent thinking. Here, the goal is pure quantity. Just get as many ideas out there as you can. No bad ideas, no matter how crazy they sound. Then, we switch gears to convergent thinking. Now, the goal is quality. We start to filter, to analyze, and to pick the most promising, most viable solutions from that big, messy list. And here's the toolkit you'd use for that. For going wide, that divergent thinking, you've got things like brainstorming or Kaizen events, which are these intense, rapid improvement sessions. Then, for narrowing down, the convergent part, you use tools like benchmarking to see what other successful companies are doing, a cost-benefit analysis to see what's practical, and FME, that's failure modes and effects analysis, which is a fancy way of figuring out how a solution could fail before you even try it. But just having a bunch of great ideas isn't enough. We don't just pick one and hope for the best. No way. Now we get to the really scientific part of the improve phase, testing our solutions with actual data to prove they're going to work. A huge part of this is a powerful tool called design of experiments, or DOE. Now, it sounds really complex, but this analogy makes it so simple. It's like perfecting a recipe. Instead of just changing one ingredient at a time and guessing, DOE lets you test how different combinations of ingredients and temperatures work together. You find that perfect mix way, way faster. And here's how you can actually do it. It's pretty straightforward. First, you identify your key variables, your factors. Then, you set a few different levels for each one you want to test. You run experiments mixing and matching those combinations. And finally, you analyze the results to find that absolute winning formula. It's all about stopping the guesswork and starting to know for sure. And here it is in action. Look at this pizza oven example. We could just guess at the temperature and time, and yeah, maybe we'd get it right eventually, but with a simple experiment like this, we systematically test the combinations and discover, based on data, that 220 degrees for 12 minutes is perfect. No guesswork, just clear, delicious results. Now, beyond DOE, there are other fantastic testing tools. Pilot testing is a classic. You try your solution in one small, controlled area before you roll it out to the entire company. Poka-Yoke, or error-proofing, is an amazing concept where you literally design the fix so the old mistake is impossible to make. And of course, simulations let you test changes in a virtual world with zero risk. Okay, theory is great, but let's see how this all comes together in a really high-stakes, real-world scenario. We're going back to that hospital emergency room to see how they use this exact toolkit to cure their dangerously long wait times. So let's remember the diagnosis from the earlier phases. The problem wasn't just the waits are long. It was a measured, quantified average of 90 minutes. This wasn't just an inconvenience. This was affecting patient outcomes. This was the specific illness they needed to cure.
So the ER team got together and started brainstorming potential treatments. And look, they didn't just settle on the first idea that popped up. They went wide. They considered everything from staffing levels and new tech to completely rethinking the fundamental flow of patients through the ER.
Now, this slide is absolutely key. They didn't just guess which solution would work best. They tested them scientifically. They used a design of experiments to find the perfect number of triage nurses. They ran a pilot test on a new patient flow in just one section of the ER, and they used Poka-Yoke to error-proof their digital intake forms. Every single cure was validated with data.
And here it is, the results of that disciplined scientific approach. They didn't just nudge the wait time down a little bit, they slashed it from 90 minutes all the way down to 35. That wasn't a lucky guess, that was the direct result of a perfectly executed improve phase. That's the power of having a real treatment plan. But finding the cure is only half the battle, right? A truly successful improvement is one that actually lasts. We have to make sure the process doesn't slowly slide back into its old bad habits. And this is where we start setting the stage for the final phase, control. And, one of the best ways to make sure your fix sticks is to avoid these common traps. Each one of these mistakes doesn't just mess up your solution now, it makes the next phase, control, basically impossible. If you haven't validated the real cause, or if you skipped training your team, your solution is built on sand. It's just a matter of time before it all falls apart. And that brings our main analogy full circle. The improve phase is what found the cure and administered that initial treatment. The control phase, which we'll tackle next, that's the long-term plan. It's the ongoing medication and the lifestyle changes that make sure the illness never ever comes back. So, if there's one thing to take away from all this, it's that real, sustainable improvement is never about finding one single magic bullet. It's about designing, testing, and implementing the right, data-driven treatment plan. So I'll just leave you with this question. What problem in your world is ready for a cure?